Imagine for a second that AI isn't just a really smart chatbot, the kind that writes your emails or helps you debug code. What if instead it was a fully interactive simulator of reality itself? A system that doesn't just talk about the world, but actively visualizes, understands, and literally manipulates the physical rules of a multidimensional space.
Welcome to The Explainer. Today we're diving into a really profound technological leap. We are moving away from just predicting the next word in a sentence and stepping right into an era where AI predicts physical consequences in 3D space. We're going to unpack the fascinating science of AI world models. This is a concept that is rapidly shifting from, abstract theory in research labs to a totally tangible reality. It's a technology with the power to reconstruct our world, and honestly, it might even change how we understand truth and liability.
We've got a lot of ground to cover today, so here's our roadmap. We'll start by looking beyond large language models, then we'll define what a world model actually is. After that, we'll explore DeepMind's Genie 3, simulate some what-if legal scenarios, and finally unpack the ethics of counterfactuals.
Okay, let's jump right into Section 1, Beyond Large Language Models.
Right, so currently, LLMs are kind of trapped in this reactive loop. Don't get me wrong, they are incredible at language, but they don't actually understand the physical world. World models, on the other hand, are fundamentally a different beast. They're designed to explicitly plan and simulate actions within a real multidimensional environment. They actually have persistent memory and engage in proactive planning, so they aren't just guessing the next word anymore, they're forecasting the actual consequences of an action in a physical space.
Moving on to Section 2, Defining the World Model.
The crucial point to grasp here comes straight from Yann LeCun. He points out that a world model is essentially your mental model of how the world behaves. He suggests that for an AI to achieve anything remotely close to human-like reasoning, it has to build an abstract internal representation of an environment. It needs, common sense. Think about it. When you drop a glass, you know for sure it shatters. A language model knows the word shatter often follows the word drop. But a world model? It actually simulates the physical breaking.
Building that kind of digital brain obviously requires a very specific architecture. LeCun's framework relies on a few core pillars. It uses perception and encoding to basically compress vast amounts of visual data into essential structures. Then it pairs that with predictive dynamics and action planning to forecast future states. It also uses a hierarchical structure to reason across different time horizons, and the whole shebang is trained through self-supervised learning. So this isn't just a random patchwork of tools, it's a unified, central hub for machine intelligence.
Let's look at Section 3, Genie 3, Generating Interactive Worlds.
Now, Google DeepMind's Genie 3 takes all that abstract theory and makes it an incredibly tangible reality. It's a breakthrough proof of concept that generates fully playable, consistent 3D environments just from text prompts. And it's doing this in real time at 24 frames per second in 720p resolution while actually keeping the environment consistent for several minutes. It reacts frame by frame to what you do, so it remembers that a tree you passed a minute ago should still be exactly right there if you turn around.
And it goes way beyond just walking around. DeepMind introduced this concept called promptable world events. You can literally ask Genie 3 to let you navigate volcanic terrains with glowing lava pools, or, say, simulate an approaching hurricane in Florida with bending palm trees and splashing waves. You can alter entire ecosystems or conjure up whimsical mushroom forests. Why does any of this matter? Well, because these generated worlds act as a limitless dynamic training curriculum. It allows embodied AI agents to learn how to interact with countless super complex scenarios, all safely inside a simulation. Which brings us to Section 4, Simulating What-If Legal Scenarios.
Let's zoom out and look at the real-world stakes here with counterfactual world simulation models, or CWSMs. Researchers are now exploring how AI can take super-limited evidence from a traffic accident, like maybe just a short CCTV clip or dashcam footage, and reconstruct a highly realistic 3D simulation of what actually went down. But here's the profound part. It can explore alternative timelines to figure out causation.
The CWSM operates in 3 distinct steps. Step 1 is evidence assimilation, where the AI weaves together diverse data, video, audio, witness text, you name it. Step 2 is reconstruction, where it builds a 3D ground truth, maybe revealing the driver was going 40 miles per hour. But Step 3, this is the real game changer, counterfactual simulation. This is where users run what-if scenarios. You can literally ask the AI, hey, would this crash still have happened if the driver was going the speed limit of 25 miles per hour instead of 40? We're already seeing early versions of this in action with models like Prism 1. The AI can completely reconstruct an intersection and then explicitly remove a pedestrian from the scene just to test a counterfactual contingency, or it can alter the speeds of the vehicles. By running these alternative realities, the AI hands legal fact finders this incredibly vivid visual evidence to determine exactly what caused a specific outcome. It completely shifts legal arguments from verbal speculation to dynamic, simulated proof.
Finally, Section 5. The ethics of counterfactuals.
But wait, if an AI can simulate reality, we absolutely have to address the ethical minefield this creates. Researchers warn that simulations must avoid perpetuating stereotypes or biased narratives. And this is a totally critical conversation. If an AI is tasked with simulating an alternative scenario to see if a teenager could have avoided a crash, we have to ensure the model doesn't just automatically insert reckless behavior into that 3D avatar just because it casually associates youth with distraction. Generative models naturally fill in the blanks of what's underspecified in a prompt, so they can very easily amplify existing societal biases if we aren't incredibly careful.
So, to protect the integrity of these simulations, especially in a courtroom, experts recommend strict ethical guardrails. This means using generic, featureless avatars during the counterfactual stage. Like, the AI needs to know the physical weight and height of the person for the physics engine to work, sure, but it shouldn't be generating gendered cues or racially specific features that might trigger algorithmic bias. We also have to restrict totally implausible physical behaviors, like a car suddenly swerving across double yellow lines for no reason. And we have to conduct rigorous algorithmic fairness audits. The AI's judgment has to remain entirely objective. As world models rapidly evolve from generating whimsical mushroom forests to reconstructing high-stakes legal evidence in counterfactual simulations, I want to leave you with this one final thought. If an AI can perfectly simulate the consequences of our actions and visually prove exactly what would have happened if we had just made a different choice, how is this technology ultimately going to redefine human accountability in our society? It is a truly fascinating frontier, and for sure, it's one we'll be watching very closely. Thanks so much for joining me for this explainer.